The next operation we're going to look at is multiplication of sequences. So I'm going to add yet another program here. I'll call it multiplication-demo.py. And I'm going to make a variable, my list is equal to, and I'm going to take a list with a single element in it, 42, and multiply it by 10. So now I'm multiplying a list with one element in it by the scalar, which is, or by this integer. And then I'm just going to print it out. Print my list and see what we get. And notice that we get a new list which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements of 42. So if you multiply a list by a number, then what you get is you get a bigger list. Now let's say that this list was 42, 23, and 10. If I run this again, you'll see that it just keeps repeating that. It makes one list, but it concatenates 10 of those elements together, so it brings it together. You could do the same thing with a string. I'll call it istr, so that it's clear that this is a string. And if I said ABC, for example, and I ran that, you can see you get ABC multiple times. So where would that be handy? Well, you could also, if this was a list of string, now notice the difference. If I have a list of ABC and I multiply by 10, now it's a list with 10 ABCs in it. So rather than just concatenating ABC, so if I multiply the string by 10, I get ABC 10 times inside of one string. If I have a list with an ABC string in it and multiply it 10 times, I get a list with 10 ABC strings in it. So there's a little bit of difference here. But let's see how we could use that. Let's go look at listing 2.1. And right here, if you recall from that exercise, notice how we have TH multiple times. So we actually have it 1, 2, 3, 4, 5, 10, 15, 17 THs. So what we could do is we could say this is really the list, this list plus this list plus this list plus, so here I'm just changing this over to a bunch of string of list concatenations. So we have this so we have the stndrd list, and then we're going to add, I think I need this, and then I'm going to add doesn't like those pluses to be on their own separate line like that. But what I have here is I have a list of 17 THs here, and then I have a list of 1, 2, 3, 4, 5, 6, 7, 8 THs here, and then an stndrd list, an stndrd list, and an st list. So let's see if that works just doing that. And so if I put 2021, day 1, 3, yep, that still works. Well, I can actually simplify this. Because this is 17 THs, I could just make this, I could just do it this way. I could just have this times 17. So now I've got these 17 THs. And then this is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7 THs. So this could just be So now what I have is stndrd plus 17 ths, another stndrd plus another 7 ths plus an st. So I will put, just to make sure I'm testing this, for the year I'll put 2021. For the day I'll put 22, that should give me a 22nd. And then the month 3, March 22nd, 2021. It's working still. And I've taken that whole section here and reduced it down from that big long list. And by using multiply by 17, I'm adding this, I'm concatenating this list plus 17 THs plus this list plus 7 THs, and it just allows us to make things simple. So that's one of the things that we can do with multiplication. So another use of this happens when we're trying to initialize a list. Let's say that I'm going to call this none demo, and we'll see why in a moment. Let's say that I have a list, and I want to collect temperatures in a building, and so I'll call this list temps is equal. And initially, I don't have any information. I don't have any data, so I have temps, and then let's say there's 10 rooms, and one way that we can add two temps is we could say temps plus, say that one room is at 90 degrees. And to show you what happens there, I'll say temps. And so we have, when we add this, and so we could, over time we could be adding now we know we have 2 elements in there. So you can add elements to an existing empty list by just adding to them. The other thing you can do is you can say temps.append, and now my list. So either to add an element to a list that's currently there, you can do this. So let's say that we have 10 rooms in our building, and we want to see what the temperatures are. And let's say that this was temp of room 3, and this is the temp of room 7, and this is the temp of room 1. Well, okay, we've got the well, this is just the empty list. So let's say that we get to room 3, room 7. We collected the temperatures, and this is maybe the temp of room 10, and then we wanted the temperature of room 3. Well, or we wanted temp of room 7. Well, if I index 7, for example, at this point, I get an error, list index out of range, because I only put 3 temperatures in. And this is in the second position, so that's not going to work. There we have, there's our temperatures. Room 7 should be 80, but I have to know that it's in the second position. But let's say I just know that it's room 7, so I really want to get that. So really what I want to do is I want to be able to initialize this. Now I could do this. I could say 0. I could initialize this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got my 10 rooms there. And then I could say temps of room 3 is equal to 90, and I could say temps of room 7 is equal to 80. So I could do it this way, And this is how I can assign a value to a particular, element there. And in terms of room 10 is equal to 70. Of course, we're zero based, so really, we're going to be doing this type of stuff. It's going to be one less than that. And if I did that, 1, 2, 3, 4, 5, 6, 7, I'm getting, I'm getting the right values, offset by 1, but still working. And so that would work. You can see that these are zeros. But let's say then I wanted to get the average. So the average temp would normally be, would be all of these numbers. And because these are zeros, we might be tempted to add all of these up, which would give us a really low temperature, which would mean that if this was being used to automate a air conditioning unit or air handling unit, it would think it was really cold and it would blast up the heat, and we'd have really hot rooms here eventually, because if I took the average is equal to temp 0 plus, we're going to find if there's a better way of doing this later on, but for now we're just going to do this just to kind of illustrate what's going on. I should have made more like 5 because I really want the better ways of doing this. Seven, 8, 9, and that should be it. Should be temps. So if I were to add up all the temps, then the average would equal total divided by 10, and then print average. We've measured 3 rooms, and the average ends up being 24. So if this was connected to an air handler unit, you'd say, oh no, the temperature's 24, we need to pump in heat, and then these would all go up to horrible heat, and it would be terrible. So initializing with 0 is not great. We could even shortcut this multiply by 0 by just doing this to make it shorter. It would still work, but again, we're getting the averages wrong. So we really need something else. And what we use instead is we use none. None is basically absence of a value. And I'm going to, just to see what we do first, I'm going to comment this out for now and run this. And what you can see, what you get is when you multiply none times 10, you get a bunch of values none where there is no value. So this is better when you're in this scenario where you're keeping track, where you're collecting temperatures. If you don't have a temperature, you put none. And for now, if I uncomment this, I'm going to get an error, because what will happen is it says, hey, I can't add together a none with to get the average. So at least what that does is and we'll figure out, we'll learn later how to take advantage of that so that we can make sure we only add, but it forces us to only add in the elements that actually have values. And then there we can see that we're actually getting a good average now. And so none is often used. We multiply by none to initialize our list when we want to have slots preserved ahead of time. So this is often a good way of initializing your list, is multiplying none times 10. Okay, so now there's a program called listing 2.3 in your book. And so I'm going to generate that. And let's say and so I'm going to go through, building this program from scratch rather than just reviewing it so that you can see how this works. Let's say that we wanted to get a sentence from the user and then display it with a rectangle around it using characters. So this is what we want to do. Well, getting the sentence from the user is pretty straightforward, right? So let's do that for part first. Sentence is equal to input sentence. And then for now, we're just going to display it. So I'm just going to put in print sentence and run that. And so, okay, blah, 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 exclamation point. Well, there we have that. Now, okay, so we want to put a box around this. Terminals are typically 80 characters wide. So let's say we wanted to center this. Or actually, yeah, so let's do calculations. So we're going to need to do some calculations in here. In the first calculation, and so we're going to just make a variable called screen width, and we're going to set it to 80, just to start. And then, well, we need the length of the sentence. So let's see to do some of this. So we're going to say that text width, and there's a function that allows us to get the length of a sequence. It's called len. So in this function, and we pass to it, we're going to pass to it sentence, and len will tell us how many elements are in the sentence. So just to see what that is, I'll just print that text width and blah blah, and it's telling me that's it's 9 characters. Makes sense. Blah is 4 times 2 plus a space in the middle. That gives us 9 characters. So now that we know how many characters there are, let's say we want to just put this in this sentence in the middle. Well, we need to calculate a left margin. So if we want to put it in the middle of 80, well, let's see. So we'll calculate left margin. We'll set it equal to, so if the full width is 80, then if we were going to put this in the middle, we would need to say we're going to go 40 characters in minus the text width divided by 2. And we're going to want integer division because we want whole numbers. And so let's see, I'm going to display that initially, just see what that looks like. So if I say in here, well, that's 36. So that sounds like it makes sense. How can I display this sentence with that many spaces? Well, what I could do is I could say, well, I'm just going to put a space times the left margin plus sentence. And so what will happen is I will put how many spaces I need to move this into the center by multiplying a single space times the number of spaces I need in my left margin, and then display my sentence. So let me run that and see what that looks like. So again, I'll put blah blah, and look, now it's in the center. Let me run this again, and I'll put blah. And you can see, I can get this there's a lot of stuff there. Okay, you can see it's keeping it in the middle because it's calculating extra space, how many extra spaces it needs to put. Here, put 36 to get this in the middle. Now it's doing 38. So it's getting this in the middle. So now I've got this in the middle, and I need to wrap a box around it. So let's just put a symbol on the left, on the right of this initially. And what we'll do is we'll say that we're going to put a vertical bar, 2 spaces, and then another bar. So what it's going to look like is up here. I'm going to put in here a pipe character, which is actually the shifted backs. If you hit shift and backspace, that will give you. And so if I do this, and then I put a space, and that, let's see what I get. So now I've got a bar on either side. Now, okay, so now I've got my box started, and then I need something on top of that. So how do I get something on top of that? Well, I could say print. So it's going to be much the same thing. I'm going to have my space times my left margin plus, and I'll use a plus and then a minus sign for, and then I need, so I need that. So I'm going to put plus and a minus sign to take care of the same things that are here. And then I'm going to add enough minus signs to cover so I need the length of the sentence. And this will start to get messy. Maybe what I'll do is I will say that, you know, the text width. Oh wait, no, yeah, I've already got the text width, so I can use that here. So I'll put this here, and then I'll put as many minus signs just to kind of make this a little easier to see what's going on. I'll place these out. So for this to do the same thing as a sentence, it'll be enough minus signs times the width of that sentence plus a minus and a plus to then replicate this thing here. So that's going to line up with that. This is going to line up with this. And then here, you know, the sentence is going to line up with this many minuses. And let's see what happens. And we can see now that we managed to put enough minus signs over this to match up. Well, to put the bottom one, same thing. And you can see that we have a box going around it. And that looks pretty cool, but maybe what we want is we want this to be up one so that it's kind of more. So what I could do is I could also do this. I could copy this, and rather than sentence here, I'm going to have a space. So in here, there'll be a space times text width. And I'll put another one of these afterwards. And if I run that, we now have this nice box that has some space around it. This looks a little close. Maybe what I'll do is I'll add a little extra space here. And let's try that again. And not bad. We now have this out in the middle. Although the problem is that this is really actually not perfectly centered because we added these three characters in here and these three characters here. It kind of gets shifted around a little bit. So we actually need this to be done this way. Make it more accurate. We're going to say box width is equal to text width plus 6. So that's going to represent this whole length here. And then what we're going to do here is we'll change this to screen width minus the box width divided by 2. And let's see what we've got now. It's kind of off to this side. Not quite correct yet. Oh, I need to get rid of this because that's already taken care of here. So let me try this again. And there we go. Now it's actually centered. So this program is in your book, a little bit slightly different, but basically the same way. And it's a way of, you can get a sentence and wrap a box around it. And it shows you, here we are multiplying by integers to change the size of a sequence, which in this case we're doing this with strings, and this is kind of a practical application of that. So that concludes how to use multiplication with sequences.